The role of vitamin D in slowing biological aging is gaining increasing attention as researchers uncover its influence on cellular integrity, longevity, and overall metabolic health. At the heart of this interest lies the connection between vitamin D levels and the preservation of telomeres, protective caps on the ends of chromosomes that naturally shorten with each cell division. Telomeres serve as biological clocks, and their length is considered a proxy for cellular age. Shortened telomeres are associated with a wide range of age-related diseases, including cardiovascular disease, cognitive decline, diabetes, and some cancers. Emerging evidence suggests that maintaining optimal vitamin D levels may help stabilize telomere length, thereby potentially extending healthy lifespan. Vitamin D, while classically known for its role in calcium absorption and bone health, also exerts widespread regulatory effects on inflammation, oxidative stress, immune function, and gene expression, all of which are critical determinants of biological aging. Inflammation and oxidative stress are two major drivers of telomere shortening. By modulating cytokine levels and promoting antioxidant defenses, vitamin D may help create a more favorable cellular environment that slows telomere attrition over time. Furthermore, vitamin D receptors are present in nearly every cell in the body, indicating the systemic importance of this nutrient in maintaining genomic stability and cellular health. Higher vitamin D levels have been associated with longer telomeres in several population-based studies, suggesting a protective effect. While the exact mechanisms are still being explored, one plausible explanation is that vitamin D may influence the expression of telomerase, the enzyme responsible for rebuilding telomeres. Although telomerase activity is generally low in most adult somatic cells, even modest changes in its regulation may have cumulative effects on cellular longevity. Additionally, vitamin D's impact on the immune system, particularly in reducing chronic, low-grade inflammation, could contribute indirectly to telomere preservation, since inflammatory signaling accelerates cell turnover and telomere erosion. A deeper look into lifestyle and nutrition further supports the role of vitamin D as a modifiable factor in aging. Individuals with adequate vitamin D levels, often maintained through sun exposure, diet, or supplementation, tend to have lower markers of biological stress. Nutritional strategies that include fatty fish, fortified dairy products, mushrooms exposed to ultraviolet light, and egg yolks can help support vitamin D status naturally, while supplementation may be especially important for those with limited sun exposure, darker skin tones, or chronic health conditions that impair vitamin D metabolism. Moreover, vitamin D's interaction with other micronutrients and biological pathways opens a wide array of nutritional synergies that may collectively contribute to healthy aging. For example, vitamin D works in tandem with magnesium, a cofactor necessary for its activation and utilization. It also complements vitamin K2 in supporting calcium balance and cardiovascular health, two factors that are closely linked to aging and longevity. Furthermore, vitamin D has been shown to positively influence insulin sensitivity and mitochondrial efficiency, both of which decline with age and contribute to metabolic dysfunction. Psychological and neurological well-being, too, may be influenced by vitamin D status. Research indicates that higher levels of vitamin D are associated with a lower risk of depression, cognitive decline, and neurodegenerative diseases. Since brain health and telomere integrity are both sensitive to oxidative stress and inflammation, vitamin D may offer parallel protective effects across multiple organ systems. The neuroprotective role of vitamin D likely involves modulation of neurotrophins, calcium homeostasis, and the prevention of neuroinflammation, all relevant to maintaining cognitive function throughout aging. Vitamin D's potential to act as a gatekeeper in age-related pathways also intersects with findings on epigenetic regulation. DNA methylation patterns, another biomarker of biological age, appear to be influenced by vitamin D signaling. Although still under investigation, the possibility that vitamin D could favorably impact both telomere length and epigenetic clocks provides an exciting frontier in nutritional anti-aging strategies. This adds a new layer to the appreciation of vitamin D not just as a nutrient, but as a hormone-like molecule with powerful systemic implications. The growing body of evidence invites a rethinking of public health guidelines around vitamin D. While the current recommended dietary allowances aim to prevent deficiency-related diseases like rickets or osteomalacia, higher intake levels may be necessary to achieve optimal cellular protection and longevity benefits. Personalized supplementation strategies based on blood tests, lifestyle habits, and genetic predispositions may become increasingly important as the science evolves. Overall, vitamin D emerges not only as a protector of bones, but also as a potential modulator of the aging process itself. From its influence on telomere dynamics to its broader impact on inflammation, immune function, and genomic stability, this nutrient offers a promising avenue for extending health span, the number of years lived in good health. With its low cost, wide availability, and relatively safe profile, vitamin D stands out as a practical and accessible component of longevity-focused nutrition. As research continues to clarify the mechanisms at play, integrating vitamin D into a comprehensive anti-aging strategy appears not only logical, but increasingly necessary for those seeking to maintain vitality across the decades.